Sure. So we're live. Welcome everyone to the workshop series episode 4 of Akash-a-thon. This workshop is going to be about incentivized IBC smart contracts with Archway, led by Augusto. Welcome, Augusto, who's a principal engineer. We wrapped off our last workshop with Shade. Super excited to kick this off as well. Archway is a very, very important partner in the hackathon that we're running with Akash. They're leading the integration and interoperability track with a bounty amount of $2.5K in Arch. So super excited again to kick this off. Welcome everyone who's watching, and welcome Augusto. If you have any opening thoughts, feel free to take the stage and then, introduce the builders to what you have today.
Perfect. Thank you very much for hosting me here. And welcome everybody to this workshop. I'm going to be introducing you all to Archway, which is incentivized smart contract chain built with the Cosmos SDK and connected to the interchain. So in this workshop, I'm going to tell a bit about how Archway works, about how you can start building your smart contracts in the network. A little bit about me. I'm principal engineer at Phi Labs, core contributor to the Archway network. Here are my socials. If you want to follow me on Twitter. That's pretty much it. And what is Archway? As I was saying, Archway is a Cosmos native incentivized smart contract chain. And the basic idea is that your smart contract will be able to capture value from the chain based on the usage it has. So the more usage you bring to the network, the more your dApp is rewarded and build this and accrue this value together with the network. So how does it work? It has, there are basically three models for accruing rewards. The first one being the gas rebates. So for every transaction that happens, the smart contract the transaction will pay fees. And those fees in most networks, they are 100% directed to the validators. In Archway, there are those gas rebates which are split 50-50 with the smart contract and the validator. So I will explain a bit later how this split is actually happening. The second model are the inflationary rewards, which 25% of the inflation generated on every block goes to the dApps. So this is based on the usage. So if your smart contract occupied 20% of the block, you will get a share, a 25% share on top of those 20% of the block that you filled. So as every block generates new tokens, this is the inflation, you will also get a portion of that with your dApp. And the third model are the contract premiums, which are directed 100% to the smart contracts. So this is a setting that you can enable on your smart contracts, and then you just start accruing rewards from there. And what you can do with those rewards? Well, they are added to your rewards balance, to the smart contract rewards balance, the one that you specify that you want to receive the rewards. And you can use for any idea that you have. You can boost liquidity, you can fund your team, subsidize gas fees. There are many possibilities that you can redirect those rewards towards. You can even think about something that you could swap the rewards automatically and then pay for a deployment in Akash. That's an example of what you can do. So imagine that you have a dApp that has a node deployed in Akash, and then you have this self-sustainable feedback loop that you are able to use a reward to pay for your hosting, which is amazing. As I was saying, Archway is connected to the interchain. So through Archway, you are able to also interact with many other Cosmos chains. We have many relayers already set up for mainnets, a few others for our testnets. And also there is a bunch of dApps that are already available in Archway. You can explore our ecosystem in the Archway website. And the idea here is let your mind drive you through what you can do with the interchain communication. There are so many possibilities. As I was saying, like the example with the Akash integration that you can do, you can also integrate through many other chains and have these those multiple hops of transactions that you can use and use the rewards to leverage all those interactions. So yeah. Also, one thing that we've been working a lot at Phi Labs is to help developer community with developer tooling, and we focus mainly on building nice developer CLI. We have our, and this developer CLI is basically a tool that you use to build, bootstrap your projects, build your smart contracts, deploy them to the chain, and we are about to release a version 2. So we have the alpha version ready. I'm going to show it during the workshop demo. If you feel like an explorer, go ahead and try the alpha version. It's pretty cool, many nice features added to it. And for front-end development, we also built Arc3.js, which is JavaScript SDK that will help you to integrate with Archway protocol on the front end. It's built together with Cosmos.js. So if you used Cosmos.js, you're gonna use Arc3.js quite easily. It is intended to be an addition to Cosmos.js and leveraging the reward system. One thing that's important to note here is that Archway, because of its this unique economical approach, it has some modifications to how the gas fees are calculated. So it's important for front-end developers that they use Arc3.js for the gas fee calculation in the front end, because inside Arc3 there are already mechanisms to do the proper calculation on how Kepler or Cosmos Station or any other Leap wallet and so on should submit the fees. So this is an important thing to note here. And there are more tools coming on the pipeline, ID extensions, smart contract debugging tools, gas estimation, and so on. There are many more things to come. This here on the right side is our docs websites. There are a lot of resources there. Go ahead and dive on it to explore what you can do with Archway. And at Phi Labs, we also built this platform called Area 52, which is a platform for people who want to learn Cosmosm and Rust. Because learning Cosmosm with Rust, it's a steep learning curve. We know about it. It's not easy for people coming from other languages. So for that, we built this educational platform that goes step by step on each of the important topics and introducing Rust concepts as they are needed in a step-by-step basis. So it's really built in a way that it will hold you by your hand and guide you through the entire course. We are working on new modules for it. So yeah, stay tuned for something coming. But yeah, That's this is the gist of the tools we have. And to the second stage of this presentation, I'm going to talk about how you can use the value capture chain in the smart contracts. So first, gas rebates. As I was saying, it's a fair split between 50-50% for the smart contract executing the transaction and the validators. And the rebates are based on the smart contract consumption. So how does it work? For a transaction, when you submit a transaction, for example, you're executing a contract, and there are many handlers in the Cosmos SDK that they do like signature verification and so on. There are many steps happening until the WASM call actually happens inside the protocol. And this orange box is actually the smart contract being executed. And then at the end, the WASM call finishes, and then there are other steps happening inside the protocol. So the transaction fee you pay, sorry, forgot to add. In this example, imagine that there is another contract being executed. And this other contract being executed, let's call the contract the orange one contract A, the black one contract B. So the contract A called B, and this was the equivalent of 50% of the execution of the contract, of the entire duration of the contract A execution. Okay, so just keep this in mind for this example. And then imagine that for this entire transaction, it was the user paid 3,000 Atom Arch. This is an important distinction. Maybe you're used to UAKT for Akash, which stands for micro Akash, right? In Archway, there's another denominator. It's not using the 6 decimal places. It's using 18 decimal places. Sorry, not plates, places. So that's why there's this other denominator, which starts with A, just for it's A for Atom. So just for you to notice this difference. So here, this execution consumed 3,000 A arch in total. But from these 3,000 A arch, only 2,000 corresponds to the smart contract execution. And what does it mean? It means that from those 2,000, the rewards will be 1,000 arch. Why? Because it's 50% of the contract execution that's going back to the smart contract, right? So it's not the entire transaction block, because there are things that happen that are related to the protocol itself. So it's only the smart contracts. Sorry, I forgot to update this box here. It shouldn't be 50 U arch. It should be 500 A arch. Okay, so sorry for the mistake. Just yeah, and then and this one is correct. So here, what's going to happen? The first contract, the orange one, since it called another contract, the second contract will also get rewards, and those rewards will be split accordingly between those two contracts. So since contract A called B, and B corresponded for 50% of the execution, so from those from the rewards that the contract is capable of receiving, it will be split evenly between those two contracts. So this is important because it doesn't. This model doesn't allow for proxy contracts to profit on top of other contracts. So imagine that you have, if we didn't have this, imagine that we have DEX with these with their swap contracts, and then you could just build another contract on top of it to do the swaps for you, and then you would get the rewards back. Because you would just build this proxy for the other contract, and then this would be an unfair split of the rewards. Yeah, so that's it for the gas rebates. Moving ahead, we have the inflationary rewards, which as I was saying, it's a bit more complicated. It's not hard, but let me try to explain it better. So the inflation in Archway is similar to the one in Cosmos Hub, is between 7 to 20% annually. And this inflation is shared with the dApps. So 25% of the inflation will go to the dApps. And this is based on how much of the block that smart contract filled. So if the block has 1 million of gas and the smart contract filled, I don't know, 50%, okay, let's make yeah, 50% of it. So it filled like 500,000 gas in gas. So and imagine that that block generated, I don't know, just to make it easy, 1,000 new Arch tokens. So from those 1,000 new Arch tokens, since the smart contract filled 50% of the block, the smart contract will get 25% of those 50%. Okay, so it would be like 500 Arch tokens, and then from those 500, 25% of it, so 125. And for the contract premiums are just a flat fee on top of the transaction. So in this previous example here, imagine that the transaction costs 3,008 Arch. If we set a flat fee or contract premium on this smart contract of 1,000 Arch, then the transaction will cost 4,000 Arch. And this difference, those 1,000 extra, will be directed 100% to the smart contract. So, and this is pay for what you use. So if the transaction fails, this fee is returned to the user. They only pay for it if they really execute the transaction. And it's an opt-in feature. You have to enable it. And the same for the gas rebates. Okay, so they are not enabled by default because you should specify targets for receiving, for accruing those rewards. Yeah, and those flat fees you can use for imagine that you have like a fixed cost on something, or you have like an NFT collection that you want to charge a fixed fee on transactions for that NFT. So those are examples on how you can use this flat fee feature. Yeah, so diving a bit more into how to enable the contract rewards. So as I said, it's not enabled by default. And after you deploy, after you have your contract ready, you have the WebAssembly compiled, and you store it on the chain, you instantiate as usual. Then after that, you should execute a transaction to specify the contract metadata. This contract metadata will set the metadata, well, will set the information of who is the admin for the contract metadata and also the rewards address. So you have those two fields there. The contract, the metadata admin, imagine the following. Imagine that you have your, you have a smart contract that you want another smart contract to control the metadata of the smart contract. You, as a developer, you could deploy both smart contracts, and at the moment you set the contract metadata, you can set the owner of the metadata to be the other smart contract. So this is useful, for example, if you want to have a smart contract that, imagine that you have a DAO smart contract and another one that is your dApp, your NFT marketplace or your DEX, whatever. And then you have the DAO controlling what's the destination of the rewards. So for that to happen, you either have to deploy the second smart contract through the DAO, or you deploy it as a developer and then you set the metadata with the owner of the metadata being the DAO. So that's how it works. And then you can specify the contract premiums, which are, again, optional. And then after that is set up, you start accruing rewards in the destination address. One thing that's important to note is that the rewards, they are lazy. It's a lazy model. It's like the staking rewards. They are not sent directly to the destination, to the rewards address, because this was our original design. But then we thought that doing this will not enable more elaborate use cases for the rewards. So imagine that you have, for example, again, the example of the DEX, that you have your pools, and you want to reward the users who are providing liquidity to the pools based on how long they are providing this liquidity. So you have the initial block when they started providing, the block when they stopped providing, and so on. And then when you withdraw, if you have these those rewards being sent directly to the destination address, the rewards address will just have the balance being increased without knowing where the rewards came from. So with that, it won't be able to understand how to properly distribute those rewards to the users. But if you have a lazy model instead, where the developer has to actually trigger a transaction to withdraw the rewards, then at the moment those rewards are withdrawn, then there is this metadata information specifying, okay, those are the rewards, those are the blocks where the rewards were created, and then you can act on that. And yeah, with that, enable more elaborate use cases. How do you add those rewards to your contract? So for that, we created those Archway bindings. It's a Rust library that you can add to your smart contracts. Very easy to interact with. Those are the basic messages you have. So you can, from inside the smart contract, you can execute all those messages, update the contract metadata. And as I said, you can set the owner address, the rewards address, or also set the flat fee, and also withdraw rewards. And for the Archway query, you can, yeah, as you can see here, also queries for the rewards model. So yeah, now I think it's a good time to jump into the code. I don't know if maybe that's a good moment to ask if someone has questions regarding the presentation before we jump to the code. But yeah, feel free to oops, sorry, feel free to shoot them, and we can answer on the go. Okay, so as I said, first thing, I'm gonna use the Archway, sorry, I'm gonna install the Archway CLI, but the Archway CLI version I'm using is the Archway CLI Alpha. I already have it installed here, so I'm not gonna install it again. Okay, so here it is. If you just install the Archway CLI without this alpha command, you're going to install the version 1 of the CLI. So this help command will be different. You have more or less the same set of functionalities. The version 1 has a bit less for sure, but the core are of the functionalities are more or less the same. But yeah, for this demo, I'm gonna go with version 2. And as you can see, we have here, yeah, commands for managing accounts. So your local wallet, configuration options, and commands to manage your contracts and to interact with the rewards model. All right, so I'm going to start with creating a new project here. So it's going to be called Akash Workshop, and I'm using these increments templates, calling this initial contract increments as well. So this is we have a repository with a few templates, so you can you don't need to start from scratch. You can start with basic templates. I'm going to deploy it to our testnet called Constantine. And I'm going to start with full templates just to have something that we can build and deploy. This usually takes a bit of time because it's compiling in Rust. Let me just get a simple folder. Okay, so we have the project ready, and let's start with it. Okay, so first thing, this project is set up using a cargo workspace. If you're new to Rust, I'm just gonna try to keep this really not dive into many Rust details, but yeah, just explain the important concepts. But yeah, this is just like a workspace that we can add many contracts here. So the contract we created is here. It's called increments, and by default, it comes with the Archway bindings already installed for us here. So what I'm gonna do here in this contract. This contract, it's pretty simple. It's just a counter. It's the full template that's also available in the Cosmos repository. It's very simple, just incrementing a number. What I'm going to do here is to modify this contract in a way that we can iterate with the reward system from it. So what I'm going to do, the first thing, let's jump to the terminal here. Akash Workshop. Wait, is it the right one? I don't know why it created the. Okay. I don't know why the main branch is called this, but yeah, probably a bug. It's an alpha version of the CLI. Sorry for that. So first thing, I'm gonna contracts, and then I'm gonna build this contract, and the contract I'm building is this increment. So I'm going to specify the name of the contract. This will build an optimized version of WASM 5 of the contract. So what does it mean? If you just build the contract to WASM, it adds, it has some debugging bytecodes added to it. So this command will just build a cleaner version of the binary. So we have a smaller binary. So we pay less fees to store it on chain. And while this code is running in the background, I'm going to explain the main changes we will do here. So the Archway bindings repository is, as I said, we have our let me just increase. I hope this is comfortable enough for everyone to read. So yeah, as I said, we have those messages. What we need to do here is we need to be able to interact with the modules, with the Archway modules using those messages. And the goal of this workshop is to create a contract that we are able to interact with the reward system from Archway. So for that, the first thing we need to do is to change the results type. And this, as you can see, is just a type alias, right? To use the Archway message as a response type. So we have this type alias here called Archway results. And the first thing we are going to do here, let me just go back to this build. Okay, it's finished. That's fine. Okay. Yeah, I just built it earlier because then it speeds up our development process later. So the first thing we are going to do here is to change all the results types to these Archway results. So we are able to reply Archway messages to the contract. And then we import this, right? We imported it from the Archway bindings, it's here. And then we got an error here, right, in the increments. Why? Because this is not updated, so we need to change it here as well. And then we have the reset as well. That's not correct. And then we have it here. For now, to avoid wasting time, I'm going to do something that I know that a lot of us already did at some point in life. I'm just going to comment the tests. It's unfortunate, but yeah, it's just a demo. Don't do that in production, please. All right, so back to the changes. So, all right, so we have our contract that is returning the correct the correct results type. Next thing I'm gonna do is to add a message that will withdraw the rewards. So for this demo, I'm gonna just deploy the contracts, set the metadata, and as soon as I deploy the contract, I will have the contract address. So when I set the metadata, I will set the rewards address to be the contract address. So this way the contract can withdraw its own rewards. Okay, so I'm just gonna add a new message here to our execute message. So yeah, we don't need any parameters here. It's just like withdraw all rewards, and that's it. Now back to the contracts. The matcher is failing because there's a missing match. Oops, overlapping ranges are not allowed. Okay, just gonna write it. Withdraw rewards, and that's it. So yeah, withdraw rewards. Okay, that looks good. GitHub Copilot is trying to take the lead, but let's not do that. Yeah, so what we are gonna do here, we should reply with a message that is telling Cosmosm that we want to execute the withdraw rewards message in the bindings. So one great place to look on code examples here, we have this inside the Archway bindings. There is this example contract that you can use as a reference for your implementations, right? So here we have the contracts with this same example we wanna execute. So the withdraw rewards, it's very simple. Let me just get it here, so it will show you what does it mean. So yeah, whatever. This can be an arbitrary number. Okay, I will explain you what does it mean. So we have the Archway message. We also need to import the We also need to import the submessage from Cosmos. Oh yeah, and we need this. All right. So yeah, we don't need those two. We can kill them here. We also remove it. Okay. So what is it doing? Here we are just constructing the message to withdraw the rewards by limits. And what does it mean? You have two ways to withdraw rewards. One is you specify limits, which is a number of rewards you want to withdraw. And the other is which IDs of the rewards. Because as I said, since we have this breakdown of rewards where each reward has its own information about when it was generated, we have IDs for each of them. So this is just in case you want to withdraw specific rewards for a specific reason. But otherwise, we are just going to use the default one, which is 0, which means withdraw all the rewards available up to the limits that the chain allows, which I think is 25,000 rewards per request. That's the current. And then after we constructed our message, we need to reply with the smart contract saying in the response, we just tell Cosmos that, okay, we want to execute this sub message and we want to listen for the reply of this message. What does it mean? Cosmos is built on top of the actor model. And for those who are not familiar with that, the actor model, it's some quite old pattern, design pattern, that where you have actors and you have messages. So the actors, they interact between each other using messages. So that's the whole concept behind the Cosmos architecture, right? So you have the contracts, which are the actors, and you have the messages. And those messages, in this case, we are specifying that we want to send a message, and this message will go to the protocol through the binding. And then we want to listen for the reply. It's not a fire and forget. We actually are interested in the result of this message. So that's why we are saying, okay, this is the message and this is the ID of the message. I said that, okay, this can be an arbitrary number because this is just an ID that we use to control what is the reply we are receiving here. So we can even move this to a constant, for example, and call this withdraw reply ID, for example, and just move it here. This can be whatever, really. Is it use? No, okay, I think it's U. Yeah, it's U64. Yeah, okay. Just get the correct integer type. Yeah. And then, right. After we got, after we specify these, we need to write the code that actually listens for the reply. Okay. Again, just to make it a bit quicker for us. So I'm just gonna add the reply code here quickly from our example. Here's just a simple matcher. Yeah, we import this, and we also need to import the reply from Cosmos STD and the STD error from Cosmos. Okay, this. Okay. Okay, it worked. Yeah, so yeah, the reply is another entry point we can have for our contracts. And it listens for the reply message that contains the ID. And that's why we need to specify this ID here. Yeah, I'm just using another constant name. So these should be the same. So if we are listening for this reply, then we can proceed with our withdraw method. So here it will be an STD result response. Yeah. Then those we just copy. Yeah. So here we will process the withdraw of the rewards. I'm just gonna copy these. And to be honest, this code here will not do much in terms of doing anything with the rewards, actually. It's just gonna parse it and serve as an example for us to calculate what are the total rewards and add this information to to the attributes of the reply. We will and all this information will end up in our transaction history. So it's just to log and see something in the terminal later. Yeah, this does not need to be mutable. So yeah, here there is one thing that I need to add. Actually, two crates that I need to add. So actually, let me just make it a bit easier. I don't know if we need all that. Yeah, let's stick to the plan. Contracts, increments, and then here to process this message, we need to add this CERD JSON WASM crate, and also CW utils. And then, oops. Another thing we will have to copy. Just gonna add this straight into our errors. Sorry, to our helpers. One thing that's important to notice, sometimes the imports, they show like the STD, but yeah, you should always pay attention to import it from Cosmos STD, not Rust STD. Yeah, in the helpers, just import it here. All right, so everything fixed. Okay, so it's working. And okay, so that's are not being used actually. So what's happening here? We got our reply message, and we need to parse this message. We need to parse to see if it has like a result. This result comes in this form of a binary, and this binary, then we need to deserialize it from JSON, okay, because it's a JSON serialized object. So we are deserializing it to this withdraw rewards response object, okay. And this is inside our Archway bindings as well, and it simply contains the reference number and the total rewards. So I think I'm gonna just Yeah, rewards balance, normalize. I think it's, yeah, it's just because it will, this native balance from CW utils will just, if there are rewards more than one coin, it will balance and sum everything into a single coin. So we don't, instead of working with an array of coins, we are just dealing with a single coin. And yeah, that's what we use here to show the total rewards. Yeah, just mapping here to be a total, like a vector of strings, and yeah, just some shenanigans here to clean up the results. So this is the basic implementation of the code of how we will parse the rewards results. And now back to the contract builds. This should be a bit quicker because we already built some of the codes. So yeah, now what we will do, we will get this compiled was binary, deploy to the chain, instantiate, and set the metadata, and then execute a transaction to see the rewards. And then after we execute the transaction, we will try to withdraw the rewards. Okay, so it's the compiling. Meanwhile, let me just confirm Archway, Archway accounts, lists, let's see. Oops, wrong one. So, stable. Okay, so we have these dev accounts. I'm just not sure if this dev account is populated with funds from the faucet. So I'm gonna just check this quickly. Okay, it has some funds. That's fine. So let's now, Archway contracts store from our dev accounts. So, oops, sorry, did some wrong. And then yeah, increments. Okay, so we have our contracts deployed to the chain. Now we can instantiate. And we need to specify the arguments for the instantiation. Oops. So the contract is instantiated. So we have the contract address. Now we will use the metadata command to set the contract metadata. Right, so yeah, let me just use this from our dev account, and then I'm going to set the metadata for the increments. Sorry, I forgot all the parameters. I guess it's Salner, but let me just confirm. Yeah, from dev, I'm going to set this in the increment contract, and the owner address. It will be the dev account, and the rewards address is going to be the contract address that I just copied from the previous commands. I hope it works. Perfect. So we have the metadata set for the contracts. Now we can execute. Increment contract from our dev accounts, and the arguments are just the increments. Oh, sorry. Gas wanted, gas used. Okay, so maybe I should specify another. Let me see if I'm able to do that. Yeah, I'm just going to increase the gas adjustment a bit to make sure it will go through. Yeah, okay, so it worked. Now we have another, we can check the rewards. So yeah, we can query the accounts, and then we will query the smart contract accounts. This transaction, what I did here, I executed the contract using this message available here, the increment one, and this should have already generated some rewards for us. So yeah, let's see. Yeah, so we have here 0.09 const available as rewards for that contract execution. So now we are gonna execute the contract again, but instead we will call that message that we just implemented, the withdraw rewards. Okay, so transaction executed. Let me just grab this transaction hash. Now let's query again the rewards just to see. Okay, so withdrawing the rewards generated rewards as well, because it's we need to execute the transaction. So every transaction we accrue rewards. But let's check the contract balance. Accounts, balance, gets, and oops. Before that, let me get the balance for this contract. Okay, so it's not, I think the CLI is not allowing us to query the balances for something that's not stored inside the CLI. Yeah, so as you can see, the rewards we withdraw are available inside the smart contract address. Okay. And yeah, the reason why we withdraw 0.09 in rewards, and these actually the rewards accrued from withdrawing it were more than the rewards we had. That's something that we don't encourage developers to withdraw rewards for every single block, but instead wait for the rewards to accrue a bit more, so it's profitable to withdraw the rewards. Otherwise, it's just unnecessary. But meanwhile, there are other discussions in our dev community on how to improve this withdraw mechanism and make it cheaper for developers as well. Yeah, so that's basically it. And one thing that I would like to add extra is about IBC use cases. So if you navigate to our Archway docs, you will see that, well, the Cosmosm official or Cosmosm documentation was not being maintained anymore. And we thought it would be, for historical reasons, it would be good to keep it available as well as just a mirror in our docs websites. And we have as well the same, the same explanations here for how to use IBC in your smart contracts. And this is the guide you should be diving into if you want to make use of those extra examples that I told. So trying to do token swaps and then transferring this to Akash and so on. We are working on a relayer for between Archway and Akash testnets. This is work in progress. We will post an updates in Akash's Discord as soon as we have it ready. And yeah, I think that's it. If someone has questions or.
Oh yeah, Augusto, we do have a question from someone watching us at YouTube Live. So I guess for a project to quality, we should have a UI deployed on the Akash network that interacts with the Archway contract.
Yes, exactly. So the way to go for the front end, unfortunately, I won't have time to cover it here, but there's a very useful guide here. Guides, yes. So if you follow this My First Step guide, it goes through the basics of setting up smart contracts. And the last step is building the dApp front end. And here, this guide will also explain how to set up Kepler, how to work with Arc3.js, which is our the front end JavaScript SDK library we have. And yeah, it has all the steps. We have also that examples repository that you can navigate to see working example of a dApp.
Interesting. Thanks, Augusto. Very, very elaborate. But yeah, if I think that's it, I mean, we're pretty much done over here. Maybe Augusto, you'd like to, just throw some light on once again on what is the best way for someone to reach out to you in case they're facing any blockers, any question, feedback. Maybe just put out your Twitter or your Telegram, Discord once again.
Yes, definitely. So let me open X. Is it? Yeah, sorry. x.com/Elesbao. So you can find me by this handler in Twitter. Please, I think the best way to message me is if you follow me. Otherwise, I think it will just filter out the messages. And in Discord, I'm available in Akash Discord with another handler. I will. Yeah, I'm available with ELSB. That's the handler there. Akash here. So if you want to reach out, where can I get my here ELSB? So I don't know if it's possible to read here. But that's my hand.
Yeah, this is something to take note for all the hackers, builders participating in the hackathon. If you ever encounter any question, feedback, feel free to reach out to Augusto.
Definitely.
Yeah, with that being said, Augusto, any closing thoughts for the builders building with us in this hackathon?
Yeah, I wish you all the best of luck, and feel free to reach out. I'll be available in Discord to solve any doubts. And yeah, let's build this interchain future together.
Perfect. And thank you everyone for watching, and thank you for putting in your questions in the chat and very actively participating in building out. Again, the builder community, like I always say, you guys are already in the top 1% of the builders since you are shipping out actively. Thank you so much, Augusto, for being with us and taking us through this elaborate workshop today.
Thank you.
Yeah, bye everyone. Have a good day.
Bye.